I got used to recording videos, which start instantly. So I welcomed everybody long before the stream had actually started. All right, now welcome back. I'll tell everybody that we're streaming some Unreal ray tracing. No, it's not ray tracing. It's ray casting. Physics. We'll call it physics shit. Collider shit. All right, so we're going to learn about colliders. This is a new project because, as I said, the other project was just me learning about stuff, and this is also just me learning about stuff. Right now, my goal is to make a game, or rather a toy, which is really reminiscent of being stuck inside of a tilted flooding hallway. You know, like a ship that's sinking. And I have the visual in mind, and the visual in mind requires me to be able to climb. So you know what? I'm going to actually go ahead and mute the desktop mic, or rather the desktop audio. I've got it already turned way down, but this gun sound is one of the most obnoxious sounds on the face of the planet. So I don't have my headset on, and now neither do you. So hopefully it won't get us too annoying here. So I've been experimenting with trying to do some collider stuff, and I got very confused and distracted because it follows different rules than Unity, and you know it's not that different, but it's different enough that I got confused. So today what we're going to do is the same thing, but a little bit different. What we're going to try and do is set up some basic casting, some basic sphere casting, to try and see whether or not I can get it to work with the concept of climbing up shit. We will come to that. I know there are tutorials about this. I have one in the background, but it's not actually doing things the way I want to do them. So we're going to experiment with the fundamental concepts first. One of the fundamental concepts starts in this player, but we don't have to start in the player. We can create. Well, we might. Sorry, I got the hiccups. Something furious here. We might as well start in the player. No, let's start separately from the player. Now the reason for that is because it's a first. Brilliant, thank you. The reason for that is because it's a first-person game, so any sort of debug visuals that I show are going to be easier to... Why do I suddenly have the hiccups? Easier to see if they are not attached to an invisible person. So to do that, we will start with just creating some markers. We'll start with a cone here because a cone is something that has a direction, and therefore we will be able to tell what's going on with it. I downloaded a game recently, Mech Mechanic Simulator. It is made by the same folks that make Car Mechanic Simulator and stuff. And it's got some fun mechanics in it. It is a game about mechanics, which is always interesting to me because it's a really complicated niche. But I don't want to try talking about it too much. I am going to be static mesh actor. Is that going to be okay? I think we can just harvest them and put them in an actor. Yeah, there we go. So here you can see our actor. And now we've got this blueprint. We can add some casting, some collision stuff. So here in the event graph, we're going to do an on tick. And we're going to want to do some kind of casting. No, it's like a sphere cast. Trace. It's called a trace, I guess. That's fine. Perform a sphere trace against a single component. Sphere trace by channel. The first blocking hit. Sphere trace finds the kinds of objects. So this would be handy. This is almost certainly what we want. So the basic idea is that we are choosing what kind of thing we want. And as you can see, I've already added a reachables category. We're not using it yet, so we're going to just keep it all on anything that's visible. We'll switch it over to reachables later, because a reachable would be anything that has like a ladder-style grabbing mechanic attached to it. You know, like an armchair. The chair's arm not like the big sofa thing. So the question is, where do we start and where do we end? Well, because we are in this object here, we're going to start at a specific point within the object, so we don't accidentally hit the object. But I don't remember which axis is which. So if we scale it on the z-axis, okay, so the z-axis is the one we want. So we're going to come back over here. We're going to start at z of 0.5, just a guess. And the end is going to be a z of 10. But I don't know whether this is in, hold on, is this in local space? This is probably not in local space. This is probably in world space, because it has no way to know what local space would be. So we've got to get our position, don't we? Well, let's leave it like this for now, because we'll know if it's in local space, because it'll appear in the world rather than attached to the object. It's pretty basic, right? Draw debug for one frame. Oh, we do have the option to ignore self. That's fine. So this should actually be enough to get some visuals coming out of it. So let's see. And you can see that there is no sign of a visual there. My bet is that if we can look under the floor... No, I don't see any down here either. Is there a little teeny flicker of red? Did I see the teeniest, tiniest little flicker of red? No, I guess not. I don't see any sign of it in either location, so we're going to stop and change it into world coordinates. So to get the world coordinates, all we really have to do is get our... it doesn't have to be the static mesh, but I guess, yeah, we don't want the static mesh. We want the self. So we're going to get world coordinates, world position, local to world. Where's it? Just get the... Get world location. Here we are. So here we'll get the world location. What we actually need to do is get the, now that I'm thinking about it, we need to get the transform. Here it is. Now the reason we want the world transform is because it allows us to transform both points and directions. See? So we can get locations, and if we transform that location here, we'll get the world coordinate, not 5.5. We'll get the nice start. And then we can do the same thing with a second go of it. No, you are wrong. There we are. I've been working with a different toy other than this node editor, and the other toy does outlining rather than touching. So what I mean is, if you do this, you see how it highlights the instant you touch it? Well, the other toy I've been using doesn't highlight until you completely encompass it. And my instincts are all backwards now. That's fine, though. And we'll just go to Z of 10. Now, of course, that will be affected by local scaling as well, but that should be okay. This did end up being a static mesh component rather than the self. Is a self not a physical object? Ooh, what a strange conundrum. I can't drag it onto the blueprint, so my guess is that this is not something I actually directly refer to. So the static mesh component must be... I'm still a little uncertain as to how the root objects work in this paradigm. It's okay. Oh, we have a radius of 0. Maybe that was the issue. We'll know for sure in a minute here. Save and compile. I don't see any debug drawing. Now, the problem is I can't tell if there's a debug draw error, or something that's not working the way I thought it was, or whether or not I don't know whether this isn't set up right or whether this isn't set up right. It's one of those things. But what we can do is we can simply print the hit. Hit result. You can't two-string a hit. Are you? I don't know exactly what a hit is. Is this an array? Hit result structure. It doesn't tell me what. All right. It's shocking to me that there's no two-string function. It says an action taking result. It says action taking result. Mifaz is chiming in with something, but I don't know. At the top of the drop down, there are a lot of drop downs. Are we talking about here? This drop down? Actions taking a hit structure result. Yeah, but there should be some method of pulling values out of the hit. If the hit can't be two-stringed, I was looking into what the hit is made of, because I'm sure that there is some component of it that can be turned into a string. Like, say, all of it, because everything can be turned into a string. But at some point there is a hit point, a point at which the collision occurs. And I sure would like to be able to just get that. I could just promote it to a variable. Boom! Now we can set that out hit. And if we take that out hit and turn it on, we'll be able to see it in the game world, right? Maybe. Let's take a look. Nope, false. So it's not colliding with anything, but we do know that it is at least trying. Good, good, good. All right, so it could be that the trace visibility here is just not doing what I think it's doing. I think that it should be trying to collide with anything that's visible. But that doesn't appear to be the case. Well, I could always transform this into a different category of object. So I think I have to use custom for this. And we can change this from world static to... Oh no, it's a different thing, isn't it? The trace channel, visibility, camera, and reachables. Because reachables isn't an object type. Reachables is a trace type. So as far as I know, this is the part... I can't think because now there's a cop car sitting outside my house. The road on the other side of the block closed down, and now every car has to go by in front of my house, which includes roughly 500,000 cop cars every day. Well, 2,000 cop cars, 2,000 ambulances, and 1,000 fire trucks. So the collider here, this is what it is. You can see that I've added reachables as a trace channel. The default response is ignore. But I don't actually know what a trace channel is. I added it because there was a tutorial that used it. But you can see I've got an object channel called a sphere tracer, which I just named arbitrarily. And I thought that was what we were working with. I thought we were talking about an object channel. But we're talking about a trace channel. I don't know. I mean, this is all it is. It's a name and then a default response. So I don't really know how a trace channel... That's not right. I don't really know how a trace channel actually functions. So we're going to go ahead and turn on block all here and see whether that changes things at all. Nope, it does not. Now there are a few things that might be going on here. One is that it might actually be in the wrong space. I may have converted it to world space twice, but I don't think so. I think that there's something wrong with my setup of the collision system. So here is the sphere trace by channel. And for some reason, it's not actually giving us a sphere trace. And it's not giving us a debug draw either. Trace color, trace hit, draw time 5. I don't know what this means. See, we're told that we can draw the debug for 1 frame for... Okay, so this must be for the duration. 5-second duration. Which would work fine if we actually got that draw debug to draw at any point. But it's never drawing, which makes me think that we aren't doing it right. Let's go ahead and make this 100. Because maybe that's in centimeters. That would make sense. But it's still... Okay, so there it is. Now we can see it. We're in the right space. And the problem is that we are raycasting 15 centimeters. 10 centimeters. There, now it's 10 meters. And this we can make into 50. Partly Atomic came by because they like watching Unreal streams. We're learning how to do raycasting today, or sphere casting in this case, the physics kind, not the visual kind. So the idea here is that we can see exactly where the collision happened, and what we want to do is we want to set up this collision system so that it will detect grabbable objects. But we don't know what a grabbable object is. Well, let's add a grabbable object to the world. We're going to go ahead and change some of the project settings to do that. We go down into collisions here. We've got some object channels, and we called this one Sphere Tracer. We're going to change that to being called Grabbable. And we're going to go ahead and just leave it like that. And then over here we've got this called Reachables. I don't know what this is, so we're going to call it Reachable Trace, just so that I don't screw it up later on and get confused when I'm not able to distinguish between the two. So now we have an object channel called Grabbable. And we should be able to limit our responses to objects that are grabbable. So let's add a grabbable object. We'll just put it up here. And changing it to a grabbable object means changing the collision category from default to something else. Grabbable doesn't seem to be an option here. Projectile is an option. I don't know why grabbable isn't. All we can really do is select custom and then select grabbable from here. Like so. Partly Atomic says, I like the use of transform for start end there. Seems like the default pattern in Unreal is extending a direction vector. Oh, yeah, I don't know how it's normally done in Unreal, so I'm just using this very basic setup where I transform the beginning and end of the points I want to do. But I got it in the wrong units. I was thinking it was in meters and it was in centimeters. So that took me 15 minutes. Direction vectors are useful if you have a direction, if you have a vector that's changing in the local space. But if your local space is the vector, there's never any reason to extend a vector. You can just use local space. So now what we want to do is we want to limit the collisions to just this kind of object. And I'm not sure how to do that just yet. We have a trace channel, as you can see. So when I look down here at the box we created, you can see that we have a trace response. So if we set that to block, then in theory, that will be the only thing that actually gets traced. If you see what I'm talking about here, this is the only thing that's blocking that trace channel. So therefore, that will be the only thing that responds to this request to trace by channel. That's the theory, right? So we're going to try it out, see whether that works. Oh, would you look at that? It seems like it's working. Now, of course, the real test happens when we move away from it. Does it stop colliding with everybody else? Yeah, look at that. It stopped colliding with everybody else. So, I mean, we're getting a lot of spam here, but you can see how it only collides with that box. It's the only thing it actually hits. And that is perfect. If we wanted to look at what a collision response is, it is not something that renders. I'm not sure how to work with it if I can't look at it. Because obviously what I want to get is the position of the physics response. So I just need to know where the object, what object it collided with is. And in theory, that's what the hit contains. But this hit doesn't have any grabbable nodes. It's not something where it'll tell me what the hit contains. Is it an array of individual hits? Is it an object? It doesn't... Oh, so that's interesting. Ah, I see. It's down at the bottom. Perfect. Thanks, Partly Atomic. You saved my butt. I'm still in the Unity mindset. I'm just switching over to Unreal. So here you can see we've got blocking hit and initial overlap. And then each of those output nodes will have the associated C++ tooltip. Look at all these wonderful output nodes. So there are a couple of impact points. Location of the object, the hit, and the impact point. That's interesting. Okay. Good, good. All of this is great. This is exactly what I wanted. Perfect. Thank you so much, Partly Atomic. You just saved me a lot of annoying work. So this is the hit item. No, hit actor. Here it is. So this is the hit actor. And the hit actor, we're going to first off change this to not that one. Sorry, my bad. This one to one frame. And then here, we're going to take the hit actor, and this is going to be our grabbable object. So we are going to promote that to a variable, which we're going to call target grabbable. We're going to delete this variable. We don't need it anymore. Deleted. And make this visible. And we're just going to make sure that works. Save and compile. So here we can see that it's got a good ray trace going. If we select it, we should now be able to see the cube. See? And then we can just zoom over to the cube. Yep, it is the correct cube. Now if we were to move away from this, the cube should go to none. Perfect. See that? See that beautiful bean footage? I don't know where that came from. This is exactly what we need in order to allow the player to grab the object that is within their view. Now the only issue here is that we are using a sphere cast, and by the nature of sphere casts, if you have several objects, you will end up accidentally hitting the front one every single time. So we're going to need a way to get around that. There are a couple of ways around that, which we will try various types, but first let's go ahead and remodel this into a ladder, which we're going to do just by brute force. By making it look like a ladder. We don't really give a single care about trying to do it well. We're just trying to make it work in general. Okay, so. So if we're talking about what we can hit, as you can tell, if this is us, okay, and we are coming down here and we're looking up from down here, there's no guarantee that what we'll see is the correct rung. So if we grab this rung and we pull ourselves up, you can see that we're still focused on this rung, even though now we should be focused on the next rung, or maybe even the rung above that. And this is just a matter of polish. It's a matter of figuring out the exact place you start the sphere cast and the size of the sphere. And maybe you have two sphere casts, one that's like a laser beam, and then if you don't hit anything with that, you get a bigger, fatter one. You can also, however, pass this sphere cast a list of things it's supposed to ignore, and that's probably the way we're going to do it. The only problem with that is that we've only got two hands, so when we grip something, that might be the thing we ignore, but there's a high chance that we might ungrip it and move on, but it might still be in our visual. So we're going to have to maybe think about exactly how all this stuff works. But if you wanted to, take a look at the sort of, this isn't the visual we're looking for, but this is the kind of angle that you're likely to see in this sort of situation. So it's important that we have the ability to tell the player what object they're gripping to and what object they're going to grip next. And I haven't really figured any of that stuff out, but this sphere cast stuff turned out a lot easier than I thought. I thought that was going to take more than 20 minutes. So making the player do this kind of casting is the next part of the puzzle. So we're going to just open up the player's blueprint. Here it is. And we'll do the same on tick creation here. Oh, this is like an old version from the tutorial. Just delete that. So here is our on tick. And the tutorial I didn't actually end up following because it was really long. Partly Atomic says, I'm reminded of the video game character camera image where their neck is bent at a 90-degree angle and elongated to provide a decent first-person view. Yeah, so we're definitely going to have some of that to some extent, but the idea here is that we want it to feel claustrophobic. This isn't like Breath of the Wild, where climbing something involves choosing a path. This is something where there's a couple of things that are basically ladders. And when you get on them and go up them, we want to make it feel like you're struggling to climb a ladder rather than looking out over a vast, cliff face or something similar. So we are going for that confined feeling that you get when you're looking up at something at a sharp angle. Time for sphere casts. Or it's not a sphere cast, it's a sphere trace. So sphere trace by channel. There it is. And once again, we're just going to grab the things that we want to grab for this. Now, in this case, we got a character that is substantially more complicated than the previous object we were using. It's full of guns, which is obviously stupid. We don't need any guns. But we've got this camera here. And this first-person camera is attached to a bunch of random crap, right? This gun sphere is the point at which the gun fires an object. And basically, we want to do that same thing, but we don't need it to be... just grab ourselves a cone. Is it not called a cone? What's it called? Oh, there it is. But basically, we don't need the gun. So we're not going to be reusing the guns version. We're going to be creating our own. Now, since we're scaling this, we have a problem, and that is that we've scaled it. If we scale something, we end up having to worry about whether or not the range that we're using is valid. So in actuality, we do not want this scaled. So we're going to move this back up to 1. And what we're going to do is we are going to... Why is it called we? Did I type that wrong? We're going to go ahead and call this cast point. And what we really want to do is add another cone inside of that, which sounds silly, but this cone is going to be the visual for the cast point. And this one we can scale. So this one we're going to remove all of the visibility. And I mean, we can come back in here and change it later. We're just kind of hacking it together at the moment. And then we have the one inside that is visible. We can scale that way down. Nope. I'm a little bit far from the screen today. It's a little bit hard to see. So sorry if I make some stupid mistakes. So the problem is this is still going to be too big because it's in the middle of the camera. And then we're going to turn off this and move it back a little bit. It's a little bit too far forward. All right, so when we come back into the event graph here, we're going to use the cast point. And then that's going to get the world transform. There it is. And then we can use this to transform 2 points, same as we did before. There it is. It's called a location, not a point. So we're just going to go ahead and have that one at 0, and then we will have this one at, I don't know, what do you think? We can reach 2 meters? Something like that. We'll give it a radius of 50 for now, half a meter, right? Half a meter? I think that's half a meter. We're going to do a trace, reachable trace, and then we are going to show it for 1 frame. And then as before, we're going to drag out the hit and break it. And then we are going to, there we are. We're going to use the same thing we did before and make that hit actor a target object. No, that's not right. There it is. We don't need can trace anymore. We're going to delete that. That's from an old tutorial that I didn't complete. Oh. All right, so we can see that we have a red targeting reticle in front of us. That red means that we haven't collided with anything, but there, we do. See? Green, green, green. So 2 meters is just not far enough to reach some of those upper objects, but it's probably a bit wide. If we were to take a look at this in scene view, you can see that it is quite a thick raycast, so we're going to want to tone that down a little bit. So we're going to go ahead and hide. Where is the object? Did I somehow close the window? No, just minimized it. We're going to go ahead and hide the visual for the cast point. We don't need it anymore. And we are going to shrink this from 50 down to 20. Yeah, so there we are. See it? And if we want to see those guys up there, we can jump and reach them. See that? So that's the idea, right? We're going to be focusing on some mechanics that'll seem familiar because they are, basically just stolen from Shadow of the Colossus, but we're going to be in first-person mode. So, you want to climb, you'll lose your endurance steadily. You got to grab stuff and move along, but of course we're going to be focusing mostly on the endurance cost of moving from point to point rather than the endurance cost of hanging on. But it's all for the future. It's all stuff we're working on. Problem is, of course, that I don't know how to make a first-person controller or any kind of character controller reach up and grab something. That's just not something that I've figured out yet. Character controllers are always quite a challenge. They're always quite complicated. And I think that what we have to do is replace the default movement with custom movement. So that's what we're going to try. We're going to try that. So first things first, we have to make it so that when we click, we attempt to grab something. We don't actually have the ability. So I don't know how to tell the game to highlight an object. I know how to create a shader that has a highlightable option, but I don't know how to move that from the player controller to the object. So we're not going to bother at the moment. We're gonna kind of just blindly hope that we're pointing at the right object. Still, that is something that we're going to have to work with. Maybe what I'll do is create like a virtual ghost hand or something that goes to the object in question. Why don't we do that? Let's go do that now. That'll make things easier on us. So in order to create a ghost hand, we are going to want to use, I don't know, a sphere. We'll go ahead and just add it inside of the cast point for now. There's our sphere. We'll call it hand. And this ghost hand sphere thing is perfectly sized. No, it's a little bit big. And we're going to want to change the material to literally anything else. Red. It doesn't seem to, there we are. That seems to have worked good. So now that we've got this set up, what we're going to do is move it to the location of the object. And if there is no object, we'll turn it invisible. Partly Atomic says that it's a bit annoying to set up, but primitives can have a stencil value associated and then look for that in a post process. I don't know how to even start setting that up. I did do some post-processing stuff, but I'm going to have to look up stencils and primitives. Unreal stencil primitive. I'll just type that into Google for now, and we'll come back to that later. Unless you happen to have a tutorial on hand for that, in which case I'll start with that. But for now, we're going to be okay with the ghost hand, a fake ghost hand. So the idea here is that Tom Lumen has a good outline tutorial, but it takes a bit to set up. All right, well, I'll take a look later on. This is valuable stuff for a newbie like me. So we're going to just grab this and use a set visible. And of course, we're going to set that equal to the return value. And that will allow it to just exist when there is something to grab. Similarly, if there is a grabbable object, we are going to want to move the hand to it. However, we don't want to move the hand to an illegal value. So what we want to do is we want to have a branch based on whether this is true. And if it is true, we want to assign the position. All right, let's see whether our red hand actually highlights stuff now. Yeah, look at that. Basics. All right, so that's going to make it easier to tell what the heck we're looking at. And now the next option is that when we click, rather than doing this extraordinarily loud gunshot, which is the reason I've got all my desktop audio turned off, we are in fact not going to do that. We are instead going to somehow grab one of these objects. So if we look at the rest of this, we've got this entire spawn projectile nonsense, right? So we want to take this input action fire and we'll move that down here out of that nonsense. And then we'll just delete the entire block. There's nothing here that we care about. Goodbye. And then we can comment this block because this is more or less complete at the moment. C to comment? Yeah. So we're going to call this find ledges handles. So we got a jump. We got, oh, look, another cop. All right. So once we get this input action fire, we're going to need to, if we have an object that we're grabbabling, we're going to want to set that as the grabbed instead. So we're going to need to check and see whether or not the grabbable object is valid. Can we use the other one? There we are. And if it is valid, we're going to want to set it as a new... Okay, what the heck? Is this broken again? Oh, it's fucking broken again. Hold on, I gotta restart Unreal. The newest version of my NVIDIA drivers is terrible. I should either roll it up or roll it back. You'd think they would test these things. Rebooting. All right, there we are. We are back. So now that we're back, we might be able to actually drag this off and get a pop-up. Look at that, wonderful, right? And we'll just call this a Grabable Object. New drivers conspire to randomly crash whenever he uses real Unreal games. Yeah, NVIDIA is not at the top of my favorite list here. I was astonished at the number of bugs this most recent NVIDIA card has, including things like you play an indie game that screws up the local indie game preferences for OpenGL defaulting, and suddenly every window that you ever open for any video game or application has random words across the top. I think it says no VC or something like that. And it's like, why is that even a thing? And the way you fix it is you go into NVIDIA and you clear out your global settings. And it's like, why did you let a random indie game set my global settings? I'm sure they didn't mean to do it. Why is that possible? Whatever. So when we set the Grabable object, that's really all we want. But we're going to want to just make sure this works. And then once we find out that it works, make that visible so we can tell. Once we find out that it works, we're going to try and turn off our default walking. So clickety, and then we'll just take a look. Yep, there it is. So that's all well and good. Now it's just a matter of deleting all these guns. Partly Atomic says that they're sure at this point NVIDIA drivers are 590 megabytes AAA compensating driver hacks and a 10 megabyte driver that indies have to write on their own, or write their own hacks against. Yeah, I mean, OpenGL is one of those things. This is just VR crap. Much better. All right, so now we've gutted it, but we need to be able to turn off the player motion. And there should be a character controller in here. I don't know what the difference is between an R and an L motion controller. Presumably this one is a VR. What's an L versus an R? They're the same class. Left, right. Why would you have a different left and right motion controller? And why would one of them have a VR marker in it? Okay, hold on. This isn't the motion controller that I care about. This isn't the character motion controller. This is like the VR hand tracking controller, isn't it? Yeah, I don't give a shit about that stuff. This camera. It's not a scene component, so it's underneath everything. Oh, there it is. You're right. Perfect. Thank you. So I just hadn't scrolled down far enough to see it. So this is the character movement, and in theory, we should be able to tell it to turn off movement by telling it to go into another movement mode. Set movement mode. And you can see there are a few different movement modes, and we can just use custom, maybe. We'll give that a shot. And then what we'll do is, if there is no current object selected, we are going to unset the grabbed object and repeat the whole process. But to turn everything off, right? I could also say new movement mode none, but I want a custom movement. We'll do none for now. In the long run, I'll want a custom movement mode because I want the player to be able to wiggle, well, you know, push their way up or down, that sort of thing. For now, we're just going to live with this. So. All right, so if we were to click, all right, look at that. We're not moving, and then we can click again, and we're moving. Oh, perfect. Now the thing we need to do is we need to override the character movement with our own movement protocol. I think we're going to have to program that from scratch, you know, blueprint it up from scratch. I don't believe that we're going to be able to reuse very much existing code for that, because there isn't really very much existing code for get close to the hand and then wiggle. So we're going to have to do our own thing for that. You know, if you do know of a custom character controller part for get close to this object and then wiggle, let me know, because I'm curious. So we can just use the grabbed object existing as a check. So we're going to go ahead and block this in. Grab ledge ladder handle. So down here we have this every tick, right? There it is, the event tick. I think what we need, can we create another event tick, or do we have to only have one? I think we only have one. Yeah. So in order to actually use this, we're going to need to do a series or a sequence or something like that. Seriously? Sequence. All right, so we'll do this first, I guess, and then we will be able to use the grabbed and grabbable to determine where we want our body to be, right? So what we're going to do is we're going to lerp towards a point that is... So I'm trying to figure out how to do this without actually wandering into some walls. But let's wander into some walls first. So we're going to take the grabbed object, and we're going to check and see if it exists. Valid. And if it exists, we'll continue, and if it doesn't exist, we won't, because it doesn't make any sense to do this if we don't have a grabbed object. We're just walking around. So let's see. If we do have a grabbed object, we need to check and see whether or not we have a grabbable object. There we are. So if we have a grabbable object, then we're going to want to make our destination halfway between the two. Otherwise, we're not going to want to do that. So basically, we need to get the world position here. Is this in world coordinates? I think this is in world coordinates. It should really say explicitly. And then we're going to just do the same thing here. And then if it's valid, we're going to add them together. So we'll just do an add. There it is. We just need a switch, don't we? We don't actually need it to be a branching exec path. All we need is the other is valid. That one. And then we can do a switch between two vectors, right? How do you do that? Switch? Is it a switch? That doesn't seem right. Select. That's right. It's got all this terminology that I don't have memorized yet, so we'll just... There we are. Perfect. Perfect. Thank you so much. Streaming this has been so useful. Every week, even though I only have like 1 or 2 viewers, they always have all the answers I need. It's super useful to just be able to set that up. Just see if I can straighten this out a little bit better here. Oh, you're right. It does have a goofy terminology. Good news is I believe A is the true. If it's true, do A, right? That's correct. So once we've got this, then this is going to be our lerp point, which we'll promote to a variable. We'll call this lerp point. And that's definitely going to be set. Boom. So once we've got the lerp point, we need to move towards it, which we can do by lerping. Maybe. I'm not actually very comfortable on set world position. All right, so if we set this, oops. Come on. Need pixel perfect accuracy. We're going to want to do a sweep, I think. Yeah, that way we won't fall through walls too badly. But we don't actually want to move all the way to the new location. We want to move part way. So we're going to need to get our actor location again. There it is. Boom. And then we're just going to want to mix between these two based on something. I don't know. This is backwards. Now the tick actually has a delta seconds, which we can drag all the way over here. How nonsensical. There's got to be a better way to do that. Vinterp is another good lerp adjacent node. What's a vinterp? Tries to reach given... Oh, that's actually probably better than what I was using. Good suggestion. So we're going to go ahead and delete that. And here's our current. Oh, sorry. Here's our current. Here's our target. Does this automatically find the delta time? I don't believe it does, since it's defaulting to 0. Patoom. Okay, so I can call getWorldDelta. Great, thank you very much. That's so much better than having a long-ass line dragged across our entire blueprint. And the interpolation speed. Is this like in meters per second or centimeters per second? Yeah, let's go ahead and promote this to a variable. I want to move the fucking node. Thank you. So if we take a look, we have to compile this. So we'll just compile it. Lerp speed, we'll set that to 10 by default. And, so then that'll be our new location. That got kind of complicated in the middle there, but that's okay. Let's grab these and move them down. Try and keep this a little bit clean because this is something I could very easily forget how I did it. Partly Atomic says that he has no idea what that speed actually is. It might even be the number of seconds it takes to complete. I hope not. That would be the worst way to implement it, but we shall see soon enough. So now that we've built it, we didn't get any errors. Here we are. So let's grab something. Grab. Okay, so that was super fast. And then it gave us this massive set of errors. Execute overgraph first person. Event graph node set lerp point. So that's one of mine. Accessed none, trying to read. Why did it access none while trying to read that? That doesn't make any sense. Is this like after the game has stopped running, it's still trying to execute and it doesn't understand what's going on? Do I need to check if self is valid before that works? Well, either way, let's change the tunable here. Lerp speed is clearly way too fast. Partly Atomic is coming up with a neat trick. Right-click, and you can convert it to a checked get. I'll have to figure out what that means in a second here. So this works. It's a little bit fast still. So you see that? This is happening at a very strange time. Right-click on the get node. So I think the problem here is that I forgot to actually... So the is valid happens... See how the is valid happens here? But this happens regardless of whether it is validated or not, which means that the get... At the very bottom, convert to validated get. Okay. Oh. I mean, I guess... That just replaces the is valid. I mean, that's definitely a neat trick. I can use it to replace this. Right? Yeah, so this is the same thing. So the problem here, select executes both branches, and that's the problem. So I guess I do need to use this validated get, which is really clumsy. I wish that this was better. Let me just adjust my mic for a second here. So we're going to be using two different sets, one for the direct pick and one for the complicated pick. So this one happens if it's not valid, and this one happens if it is valid, and there's no select vector. And then they both pipe into set actor location. All right, now we're going to use a different get lerp point because there's no reason to pass it like that. So we'll just get it and then put it straight in. Delete this. No, delete this. Darn it. Move these down. Tuck this in. And there we go. And that should prevent having a million errors. How do we clear? I guess it'll clear automatically when we hit play. All right, so here we are. We can grab this. Yeah, that's good. And grab that. So I think what's happening here is that our movement is stuck. We're sweeping, so we don't move through the wall, and that's catching us on these. What we actually want to do is move to a point that is away from the wall, right? And to do that, we are going to be using the grabbed objects vectors. We're going to be using the grabbed objects forward, or something like that. So if we take a look at these bad boys here, the green vector is the one that we're currently using, and I don't know which vector that is. So Z is that one. Y is this one. So I believe that these are all going to be using the wrong vector. What we're going to do is we're going to want to... Is this... oh, wait, this isn't in local mode, is it? It must... Is it in local mode? Basically, if we were to spin these around 180, then we could use vector.up in theory. But I don't know if that's true, because it's in local mode, and I want it to be in local mode. Here we are. So now it's up. We are using vector3.up. If we wanted to, we could switch it over to being... The problem is that rotating these like this rotates them like that, which is really stupid and obnoxious. So if we wanted to rotate them so that their z-axis was pointed that way, we'd have to like type it. Nope, that's the wrong axis. Just undo. 90, right? So what is it now? Yeah, there we are. That's still the y-axis. That's annoying. All right. So now this is the y-axis? Am I... I can't tell which direction is forward on these steps. I can't even tell if this is actually the y-axis. It doesn't make any sense for it to be the y-axis. I've changed the rotation so many times that you'd think... Yeah, so I don't know. Maybe I'm just 270, huh? Okay. All right, so now blue. Okay, so the issue here is that this is still in world position. But this is the blue arrow, and the blue is Z, so forward should be Z, or is this up? Don't know. We're going to try it both ways and see what works. So in order to do that, when we get the position of these objects, we're not actually going to be getting the position of this object. We are going to be getting the position of this object plus some offset. The offset is going to have to be from the target object, which means finding the target object's forward vector, or up vector maybe, but we can't just get it because it might be scaled. So we have to find it and then normalize it. So this should already be normalized. Magic. Z is up. All right. X is forward. That's bizarre. All right, well, we'll use up then. It's no big deal. Thanks. You were hugely helpful, Partly Atomic. So all we have to do is then multiply this by a meter, and then add it. No, how would you add a vector with an integer? F vector stands for float vector. Some asinine convention morphed that into all structs must start with an F. So fint vector means float int vector. Yeah, this is not the most carefully thought out of naming conventions. We're going to leave the other one as is rather than getting the offset for reasons that will hopefully become obvious. So we're going to compile that. So now when we get this object, grab, we didn't move out from the object. We were supposed to move out from the front of the object. I don't think we are, though. Oh, is this just because... Oh, you know what this is? I have a math error. No, I don't. Do I? Yes, I do. See this? I'm just adding them together. I want to take their average, not add them together. Durr! Okay, so... why is this not... Oh, here. Can we average? I mean, I guess we can just lerp... Oh, for fuck's sake. I gotta restart the friggin' engine again. It appears that Visual Studio is not involved. Yeah, no shit, Sherlock. I don't know why you decided that you should break all of the windows in Windows to tell me that. But now that you've done so, let me restart everything for us. All right, we're back. So, getting back into the player character again. Here you are with your empty arms, doing the finger guns. And we'll just go inside again, and here it is. And I guess what we'll do is we will lerp between these two vectors at 0.5, which is just averaging them, but that's fine. That way, we won't like try and fly off into the sky. We will try and hover a little bit. Let's try it. Okay, so this is correct. Good. And then when we look up here, oh, look at that. Oh, look at that. Look at that. We can actually reach the very top one from here. Now, this is quite a bit of reach. We're probably going to want to change exactly how this math works out. But you can see that this is pretty much how I intended it. Beautiful! I got so much work done today, thanks to Partly Atomic. Mifa says, what happened? So basically, when I clicked on one of the nodes, it decided that I wanted to try and edit the source code for that node, and it tried to open up Visual Studio, which isn't installed, which caused all of the machine's Windows rendering to break due to an NVIDIA update. So I had to restart it. Not the whole machine, but the game engine. Yeah, this is good. Guys, this is good. Woohoo! And then if we just click fall. All right. So all told, this is correct. This is the kind of movement we want. There is still a lot of work to be done, like all of it, but I'm now confident we can do that work. So let's come over here, and we're going to screw this lerp speed down a little bit more. 0.5 is probably a little bit better. The other problem is that we're currently not being affected by gravity. We're going to have to take that into account at some point here. I could always simply add in an arbitrary gravitational constant. Yeah, I guess I should do that. So the lerp point here, we'll just take this lerp point and we will add in an arbitrary constant. Is z up, down? I think z is up, down. So we'll just add in a meter drop on the z-axis, or is that a meter rise? That's a meter rise. A meter drop. All right, so now hit play. Yeah, so now we're properly looking up at things, right? And this is the basic idea, right? It feels pretty solid. Now what we really need to do is add in an exhaustion mechanic, so that as we climb, we get more tired. But I don't feel like doing that. I'm feeling super jazzed because I didn't expect this to be this easy. That was 1 hour of work and I already have a climbing system. Yeah, it's dumb because I'm sitting here like holding up my thumb going going up and magically levitating. But it works. It works really, really easily and really well without any sort of difficulty. That's marvelous. I thought this was going to be hard. It turned out to be quite easy. The part about making the arms exist might be a little bit more challenging. We'll have to look into that some other day. But I'm considering just stopping now because I did everything I wanted to do and more. So thanks for stopping by, everybody. I'm going to stop here. We're going to pick this up again on Wednesday, and who knows? Maybe we'll do arms, hands, something. We'll have to work it out. And I will see you folks around. Thanks for coming by, everybody. You were super helpful.